Snell's law tells us that the refractive index of a material a wave travels in initially, multiplied by the sine of the angle that this wave hits the interface, is equal to the multiplication of the refractive index of the adjoining medium and the sine of the angle of the wave leaving the interface. This law can be better expressed if we define some terms first. The line between two plane media where they meet is called the interface, or boundary. The angle at which the wave enters this boundary is called the angle of incidence, and is measured from an imaginary line called the normal. The normal is a line perpendicular to the boundary, and needs to be added into any diagram representing these scenarios as a dotted line to show that it doesn't really exist. This normal has a counterpart on the other side of the boundary in the new medium. This is called a normal again, and is used to measure the angle of the wave coming out of the boundary. The angle between the wave coming out of the boundary and the normal is called the angle of refraction. Going in is incident and coming out is refraction. Snell's law allows us to determine the refractive index of a material given the refractive index of the other material and the angles of incidence and refraction. We can also work out the angle the wave leaves the interface if we know the angle it entered at, and the refractive indices and the materials involved. In short, if we know 3 of the 4 variables in Snell's law, we can work out the other variable.